Okay, in the last video we were talking about this thing called partial fraction decomposition, and there's one more example I wanted to go through, kind of one of the more complex things that can pop up. And suppose I have this, and it's already factored out for us, the denominator, and here I have an x minus 4, and I have an x squared plus x plus 4, which cannot be factored out, not in the real numbers, only in the complex ones. So the question becomes, what do I do then? If I can't factor it anymore, if I can't make it a linear factor like the first one, what do I do? And there's a trick here. I'm still going to write this out, in this case, as the sum of two factors, because that's all there are, x minus 4 and x squared plus x plus 4, just like before. Here, the first one, x minus 4, I know I write an a. For the second one, I write bx plus c. And there's an idea here, the trick. That is a linear factor on the bottom, degree 1, polynomial degree 1. In my numerator, I put something that's 1 degree less. That's a constant degree 0, which is what we have been doing over and over. Here, this is a quadratic polynomial on the bottom, degree 2. So I put a linear polynomial on top, bx plus c. The numerator is 1 degree less than the denominator. And again, that's in terms of the factor. On the last video, we had one where the final term was something like x minus 5 squared. This is still a linear factor that is squared. When you reduce it, it can reduce to a linear factor, so I put a constant on top, but then that linear factor is squared. Here, this is irreducible. You can't reduce this to a linear factor. It's quadratic. So understand the difference between the two. We did these in the last video, linear factors raised to powers. This is a quadratic factor that cannot be factored anymore. It's irreducible. But now I do the exact same setup as before. I find my common denominator, and because it'll be a little bit messy, maybe I can do it over here. X squared plus x plus 4 gets multiplied on top and bottom. This is going to be too messy to write on the bottom, but we understand. Write it on both places. And then x minus 4 here. And I end up getting, let's see, the first one becomes, if I write it all out, ax squared plus ax plus 4a. The second one I'm going to have to FOIL. Bx times x is bx squared. Bx times negative 4 is negative 4bx. C times x is cx. C times negative 4 is negative 4c. I'm not going to bother writing out the denominator because, again, we only actually care about the numerators. But now, once I have that, once I account for this trick with that irreducible quadratic term, everything is the same as before. So I get, on the left, 5x squared minus 4x plus 8 equals, on the right, ax squared plus ax plus 4a plus bx squared minus 4bx plus cx minus 4c. And now I just equate the terms with the same powers. 5x squared equals ax squared plus bx squared. Those are done. Now I do the linear terms. Negative 4x equals ax minus 4bx plus cx. Then my constant terms. 8 is equal to 4a minus 4c. And then drop all my x's, because they don't matter now. They all divide out. And I have a nice system to solve right there. I'm not going to bother to solve this one out. Again, we've done the systems of equations enough. But in this case, if you divide the bottom equation by 2, the whole thing, you get, divide it by 4, I'm sorry. You get 2 equals a minus c. So a is equal to 2 plus c. Then I can stick it up in here and solve for b. then plug that result into here, get C, then go back here, then go back there, and it'll work nice and simple and straightforward with substitution. Again, I just want to make sure we understand the trick of how to break this up. So the last one, which we are definitely not going to solve out, but just to make sure we understand the trick and how convoluted this can become. And it actually does happen like this in Calc 2. Suppose I have x to the fifth plus x squared plus 7x minus 14 all over x squared plus 5x minus 2, x minus 1. How would I do the decomposition? This is already factored, so I understand the trick. I'll just start listing them out. That's an x squared, which is a linear x raised to the square power, which means I would have the x factor, then I would have the x squared factor, all the powers of x. This is an irreducible, so that's a quadratic factor that can't be reduced, x squared plus 5x minus 2. The last one is a linear factor, x minus 1. Then I would list all my numerators. This is linear, so that's an A. This is a linear thing squared, so that's still a B. This is a quadratic factor, so I put a CX plus D. I just keep going alphabetically. This is irreducible quadratic, so that's linear. This one is just an E. And now, well, I have 5 variables to solve for. Bear with me, I'm going to sneeze. Okay, now I have 5 variables, constants to solve for, which just means I need 5 equations. I'm not going to solve this like I said, because this board would be big enough to write it all out, but the principle would be the same. Find the common denominator, just product of all of those, multiply appropriately, FOIL, distribute, do all the algebra, then set this, the whole new numerator you get, equal to that, equate all the common factors by power, and then solve the system of equations. Don't bother trying to solve this out, it would just be really, really messy. But like I said, once you understand the trick of partial fraction decomposition, it can just become more and more convoluted, and you can solve more and more tricky problems, which is actually why we do it and use it in Calc 2, because we need it.